Hey guys, it's the other Jason here from 3D Printing Canada. So today we're going to show you what you can do with a drill bit, a bushing, a tap, and a tap bushing. If you ever needed to know anything about extrusion, attaching, and putting it together, this is the video for you. So if you've been in and around 3D printers for the last little while, you will notice that 90 to 110% of what's out there uses extruded aluminum to assemble them, put together. A lot of them will use the extrusions for motion systems. The V wheels will run in the wheels. One of the hardest things to do with extrusion is to actually get it to tie together. So Open Builds came up with an extremely good system, and it's a very strong system of using what they call these plates, or some people refer to them as mending plates. They're available in 90 degree, they're available in T. So if you want to have a piece that comes straight up out of the middle here, you can bolt this piece on, and then you can bolt another piece of extrusion like this. So with this system, you can move it anywhere you need on here, and you can get perfectly vertical bars, no matter which style or whichever way you want to build your 3D printer. Now, these plates are extremely good. They're very strong. Use them a lot. They do have certain applications where they're extremely good. This one here is a 90 degree outside plate. They do have inside gusset plates, or gusset angles, so they would bolt in here on the inside. Straight 90 degrees on the outside here, or again another inside for more of a low load, not quite as heavy application. You can use the thin one over the thick one. All great systems. A lot of what people are starting to do a little more of is what they call blind bolting for extruded aluminum. So here at 3D Printing Canada, we've actually developed the 3D PC Build It system. So what the system basically consists of, because we're all in the 3D printing industry, we all have 3D printers currently, and we're looking to do additional things with them. We've tried to make it as easy as possible. So with our system, basically it's a combination of 4 pieces. There's a steel bushing for the threaded insert. The threaded insert is 5 millimeter. The bushing has a 5.1 millimeter hole on the inside, and the size on the outside is meant to work with our models, which I'll get to in a moment. But you have to bear in mind these are different. So there's an insert for the tap, and then there's also an insert for the drill. The drill is 4 millimeter, and the insert, the inside diameter on the insert, is 4.1 millimeter. So it's actually quite a nifty system we've come up with. So what we're basically doing in our store is we'll sell you the bushings and the drill bits and whatnot to get you set up initially. Once you get it set up, we'll actually provide to you a set of STL files. So you can download any of the model styles that you're looking for. So this one, for example, this is a printed model of the end tap. So when you want to tap the holes in the end of the extrusion, you're going to need, if you're simply doing 20/20 extrusion, you would put 1 insert in here, and you'll do 1 extrusion on the back end. If you're going to do 20/40, you can do 2, 20/60, you do 3. So that's why we're letting you buy all these ones separately. That being said, let's get back to the advantages just for a minute before I start getting into the actual assembly. So to do this, I need 1 bolt. So every one of these here has a bolt, and it has a sliding T-nut on the inside. If I actually let these go so that I can slide this one apart, There's a bolt and a sliding T-nut for each one of these holes. So you've got 10 pieces here just in this. Then you've got the plate, then you've got the 2 pieces of extrusion. Now with the system that we have there, I'm going to show you actually how to do an equivalent strength joint and with only 2 bolts. That's all you're going to need. I'm going to use these same pieces of extrusion that I have here. So let's just take this apart and I will show you the difference when we're all done. Now, this is a little bit of a precursor to us, for us. The precursor to this is we have a large amount of extruded aluminum coming in. We're striving right now to become probably one of the largest suppliers of extruded aluminum, at least in the Toronto area, if not in Canada. If you need extrusion, call us. If you need to cut to specific lengths, call us. We will be doing custom cutting on this. What we have coming in is 2020, 2040, which is what this is. We have 4040 coming, which is this size. It's exactly the same. It's just twice as deep. So this is 2040, this is 4040. We're also going to be getting 2060, which is essentially like this, and 2080, which is essentially going to be like this, but all in one piece. We're also going to be getting the extruded aluminum C channel, so keep an eye on the website. You will see it come up there as soon as it hits ground. But to go through this first, what essentially we're going to do is we're going to build a system here on the desk, and it's going to show you how to do a blind bolt system. So the blind bolt system is an alternative to using the mending plates. So again, these mending plates, there's a lot of bits and pieces you need for them to be able to work. In order to do a blind bolt, essentially what you're doing is you're utilizing the channel that's built into this extruded aluminum. Using the blind bolt, all you're going to need is a 5mm button head bolt, and you can use it in 8, 10mm, up to 16. I generally will go about 10 or 12 because it gives you lots of thread to bite into. Essentially what you're going to do, you're going to slide the bolt down through this channel on the inside of your extruded aluminum, and you're essentially going to bolt it into the holes on the end of the extrusion here that you're going to tap. So what you're going to do is you're going to use your tap, and you're going to tap the holes here. Wherever you want this bolt to end up in your extrusion on this one, you're going to drill a hole through it on the back using your drill bit. So once you get your bolt laid in place, you're going to use your Allen key. You're going to go through that hole and operate the top of the button head bolt to actually bolt this together. And because you're not going to see any external fasteners on it, that's why they call it a blind bolt system, or a blind bolt method. Now, the one neat thing about extruded aluminum, which not a lot of people are aware, I'll give you a little bit of a zoom in on this one. If you'll actually look at the extruded aluminum, you'll notice that inside where this bolt fits, it fits in on the 2 tongues that come inside on the extruded aluminum at this point and this point. These ridges actually are bent in slightly. They're bent in at a 2.5 degree deflection, I guess might be the best way of describing it. So with a 2.5 degree deflection, when you slide this bolt in and you're going to manipulate it through the hole that we're going to drill in this side of the extrusion, when you tighten that down, you're actually preloading that extrusion. So you're going to try and straighten it out. So you don't need lock nuts, you don't need flat washers. The only thing you have to be careful of is as you're tightening it down that you don't over tighten it, because it is aluminum and it will strip out. It will strip if you over torque the bolt on the inside. Okay, so that's a general overview of what we're going to be doing. For right now, I just want to put this aside and go through the actual details of what you're going to see in the kit. Okay, so as I've mentioned in the kit, we're going to have 2 bushings, one for the tap and one for the drill bit. This particular one here that's printed, that's again in the STL package, you're going to take, this one is for drilling the taps in the end of the extrusion. So you're going to want to use the larger bushing, and that larger bushing, you're going to clean out these holes, and this bushing is basically going to get press fit into the end of this plastic piece that you're going to print. So when you do that, there's a couple of different ways that you can actually get that bushing in there. Now, I don't have these holes cleaned out at all. It's literally fresh off the printer. But there's a couple of different ways you can try. So if you have one of these carpenter clamps, might be an easy way of doing it. So you can lay it on the top here, and then you can manipulate this to actually press the bushing through the plastic this way. That might be one way of doing it. The other way that you can do it is simply use a pair of slip joint pliers. It'll go in there a very similar way as well. When you put them in here. Now you have to bear in mind, you also don't want to crush your plastic, so I don't necessarily know if I would go this way with it, but you can actually take it and manipulate it to be able to press fit it in here as well. Okay? So whichever method you choose, whichever way you get it in there, you might have to clean out the holes in it a little bit, depends on the tolerances of your printer. That's going to be the deciding factor on a lot of it. But our models are designed with a little bit of tolerance to be able to press fit those fittings in there. Once you get these press fit into place, they're not something you're going to want to pull out every time. Once you press fit, they're in, they're done. So if you want to start extruding, or if you want to start drilling 2040, 2060, you may have to pick up multiple bushings, which is fine. So one of the rigs that I have done already, due to the magic of television, this is what it will look like when it's complete. So with this one here set up, I have it screwed to a board at home, have one screwed to a workbench, wherever you're going to be doing most of your work. You are going to be pulling pieces of aluminum out, and you are going to have a little bit of scrap left over. So I wouldn't recommend doing it on the kitchen table, just because the cleanup will get bad. So that being said, you can grab a piece of extruded aluminum and you can put it into your jig. And when you put this into the jig, you're going to want to make sure that this gets pushed all the way to the edge into the bottom. Another part of the kit that we also include are some of these support pieces. So with these support pieces, they'll basically come in on the back end, and depends on how long you do yours is where you're going to want to adjust this so that it gives you a little bit of support on it. But you can sit down and do it, and when you lay it down in place, it doesn't allow this to move anywhere. So it holds it nice and firmly in place. Okay? So once you get it done, this is what it's going to look like, something like this. All right, so once you have your jig set up and you have as many bushings in here as you want, again, you can mount your support wherever you want it. I'm using our 3D printer maintenance oil that we have. It's actually good for linear rails and that as well. But when you're drilling these, this extrusion comes already with the holes in it. I think they're about 4.5 millimeter. What we're going to do is we're going to tap them to a 5 millimeter size so that the regular bolt will actually fit right in it. So the process of doing this, pretty straightforward. Don't over torque it because it is possible to snap this tap off inside the extrusion, and believe me, it generally doesn't come out. So you're going to want to put just a drop, maybe 2 of oil on your tap. Your tap is going to want to be lubricated. If you try and tap this without lubrication on your thread, I can almost guarantee you're going to end up snapping it off. So all you're going to do is you're going to provide your drill, let it go in a little bit, and then pull it out. Let the threads clean up, and then go in again, a little deeper. Back out again, And generally I'll go 3 times. By the third time I'm in, I'm all the way in the bottom of the tap. If you want to go a little deeper, you can pull the tap out of your drill and you can continue going deeper. The deeper you tap the extrusion, the longer bolt you can use, the stronger your joint's going to be. So as I go on to the next one, I'm just going to wipe the excess off my tap, put another drop or 2 of oil on it, and then I'm going to do the second one the exact same way. There we go. Now, take off my support. As I grabbed a couple of bolts, you will see that they thread in there quite easily. The next part of the blind bolt is we're going to slide this into the extrusion. So the next step we have to do is we have to drill the holes into this at the appropriate points of where we want to be able to pass our Allen key through. So if we want to do it on the end, because this is 20 millimeter by 40 millimeter extrusion, if you want to put this right on the very edge of this, you're going to want that hole 10 millimeters inside, or half of 20. So you're going to want the first hole at the first hole at 10 millimeter, the second hole at 30 millimeter. That will allow you to bolt it directly to the end. If you want it somewhere in the middle, you need to do your own measurements from there to figure out where to go. But we have a solution for that. So again, we've already gone through the tapping on this one, which, as you guys saw, is fairly easy to deal with. When you screw these down, screw them down just enough so that you can still slide the extrusion through, but gives yourself a little bit of wiggle room for when you're sliding this back and forth. Okay? So for the first example, let's say that we're going to want to put this right on the very end. So we're going to have to drill a hole. We're going to have to drill 2 holes, one at 10 millimeter and one at 30 millimeter. Now, a little bit of an explanation once you get this one here together. I'll focus on this one momentarily. Let's just focus on the same one as we're dealing with before. These extrusions, or these adapters, or the brackets for these, you'll notice that there is a short side and a long side. From the short side to the edge is 10 millimeter. So if I put this extrusion in, lay it on my support bracket, and bring it just to the edge, right here, I can drill this hole, and that's going to be 10 millimeters in from the face that's showing here on this bracket. So we'll just go ahead and do this one. Now, with that one hole, that allows us now to put our Allen key all the way through. And just with that alone, we can actually start tying these things together. And just like that, that's a tight joint right there. It's only 1 screw in it so far. The neat trick to doing blind bolting is, as long as your mating face here is cut straight 90 degrees, this whole joint has no choice but to be 90 degrees, because you're actually placing both pieces together on a known cut face. So let's loosen this one up and I'll show you how to get a different measurement. So now we've got the first hole done at 10 millimeter. So the next one we're going to want to do is at 30 millimeter. Now, if we look at the close-up of our machine here, of our piece, if I want 30 millimeters from the side. What I'm going to want to do, this is 10 millimeter here. So I'm just going to bring this plastic block into 20 millimeters. So 20 millimeter plus the 10 gives me 30. I can snug that down. Make sure my measurement hasn't moved. So I'm still on the 20 millimeter mark. Tighten both down. And now you can actually use this as a production run. This is now an end stop. So if you have 20 pieces you want to do and you need them all drilled at the same point, put them in here. You can drill this one, take it out, flip it over, put this one in, drill it here, or even if you just want to rotate it 90 degrees, put it back in, drill your hole, and they're all going to be exactly the same if you're going to bolt all the way around. Okay? So let's do exactly that, and let's get our first blind put together completely. I know, guaranteed, there are some people out there telling me I should probably put lubrication on my drill bit, and you're correct, I probably should. Do as I say, not as I do. Use lubricant, it's much better. So I can reach through the first hole, tighten down the first bolt, reach through the second one, and tighten down the second one. And with that, we have a perfectly tight, perfectly 90-degree joint with using nothing but 2 bolts. Use the exact same method if you want to connect multiple ones of these down through, or if you're doing 2040, 2060, 2080, or your C channel. These jigs, we've designed them to be as universal as possible. If you're only going to be doing 2020 extrusion, you only need 1 bushing. If you're going to do more than that, then just buy the multiples. We also obviously do sell the drill bits and taps and things like that as well. The advantage of doing this is that if you're going to do 25 pieces that are the same, this is now a production run unit. So this is done for you. So this here will be an end stop for the second larger, for the larger piece that's here. This is the unique piece for our 4040 extrusion. Again, it's included in the STL package. If you want to do 4040 extrusion, it will fit in here just fine to be able to drill your blind holes here. And again, if you're doing production work, this will also come out so you can do the end stops in it as well. These are all available when you buy the bushings. I believe the link will actually be right on the purchase page, so you can download these and actually have them printed before you actually get your bushings. And then everything should be ready to go. I just mounted mine here on just a piece of MDF board that I had here, just so I can make it mobile, move it around, do what I need to. However works best for you. Hope you guys like it. This is going to pretty well cover all of it for right now. If you need anything else, feel free. Reach out on our forum, 3dprintingspace.com, or come visit us online or in the store. Thanks, guys. Have a great day.
Hey guys, don't forget to check out our forum, 3dprintingspace.com, where there's all kinds of technical videos and everything 3D.